So in 405 BC, the Spartans took a look at their empire and decided they wanted to expand. They employed a new naval commander called Lysander, and he built up their navy and set his sight on the city of Athens. He took the navy and sailed up towards Athens. The Athenians saw him coming, so they met him halfway. There was a huge naval battle, but the Spartans won out. This allowed them to sail up towards the city of Athens and blockade the city. This blockade prevented any supply coming in and out of the city. The Athenians are pretty proud and they didn't like this, but after a year of no supply and food coming into the city, they had to surrender, and the Spartans took the city. But what does this have to do with cancer? Well, tumours, very much like cities, need blood vessels or supply routes to provide them with food and nutrient and oxygens so that they can grow. Tumours can't grow to more than about 2 millimeters in size before they need more blood vessels and food and oxygen so that they can grow. My thesis is looking at delivering a chemical called siRNA into tumours to turn off a gene to prevent the growth of new blood vessels. Blood vessels grow in multiple different ways. One way they can grow is like the branches of a tree. siRNA is kind of like the DNA in our cells, except it's made to look like a virus. It has a special ability to turn off specific genes. CLEC14A is involved in the development of these branches off of the tree, of these tumour blood vessels. If we can turn this gene off, then we can prevent this branching and growth of new blood vessels. So we take this siRNA targeted at turning off CLEC14A, we put it inside a nanoparticle, and we target this nanoparticle to the tumour blood vessels. Nanoparticles are great. They are these tiny spheres that are about 1/1000th of a meter in size. So we can stick this siRNA inside the particles and protect it from the body and natural environment. It gets to the cell and it releases this siRNA, enabling it to turn off the gene. Not only can you put stuff inside nanoparticles, though, you can put stuff on the outside. Here, on this diagram, is a nanoparticle with antibodies around the outside of it, and these antibodies can target the nanoparticles to specific cells. Also, we can put imaging probes on the outside, fluorescent molecules that shine brightly, so we can track the nanoparticles. And this is what I hope to do, to develop a therapy to turn off genes in tumour blood vessels, to prevent the growth of these blood vessels, but also to track the therapy, show that it's working, and tell us that the tumours are surrendering their cities to us. Thank you.